All right, so we're going to look at comparing these irrational expressions, but I'm going to start off comparing rational ones. So the irrational ones, what just automatically makes sense, I hope. So it says compare using, and this symbol is less than, guys. I call it the bent L for less than, not the alligator mouth, anything like that. This symbol is what I call the broken G for greater than. So comparing less for using less than, greater than, or equal to. Okay, so we're gonna start off, and I want you all to know, excuse me, that when things are mashed together like this, it indicates that you multiply. So you can read this as 2 times the square root of 16, which would be 2 times, and the square root of 16 is 4, which is just equal to 8. So this equals to 8, and on this side I have an 8. So these two are equal. If you don't understand that, you need to pause the video and let me know. All right, the square root of 49 is 7, but here it's going to be 3 times the square root of 4, which is 2, which is 6, and 7 is greater than 6. This one is 2 times the square root of 3 compared to the square root of 5. Well, this one is a tad bit different because here that's irrational, here that's irrational. Whereas the square root of 16, let me get out of that. The square root of 16 is rational because it equals 4. Square root of 49 is rational. Square root of 4 is rational. But we get over here and these are irrational. If they are irrational, guys, you're going to have to use an approximation. Because they keep on going forever. So you're going to have to use an approximation of the square root of 3 before you can multiply it by 2. You're going to have to use an approximation for the square root of 5. And then we can compare. It says, which of the above was most difficult and why? That would be number 3. Because the expressions contain irrational numbers opposed to rational. It says, can you use what we've already learned to get a good approximation for both numbers? Yeah, we sure can. We can approximate to the nearest 10 or 100. All right, so we're going to take a look at A. A is the same as 3. It says at this point we should be ready to compare expressions that have irrational numbers, but we're going to approximate these to the nearest 10. If the numbers are really, really close, guys, like if I get 2.7 in one expression and 2.7 in the other, then I'm around to the nearest 100. But until then, I'll stick with the nearest 10. And I know I had you all checking in the others, but if we can compare without checking, we're going to compare without checking, all right? All right, so let's take a look. The square root of 3, I'm going to work on the square root of 3 first. Lies between the square root of 1 and the square root of 4. So I know it lies between 1 and 2. Okay. So I know 1.0.1. I don't really have to start close to 1.0 because the square root of 3 is closer to the square root of 4 because 3 is real close to 4. So I know the square root of 3 is closer to the number 2 than it is to the number 1. Excuse me, that's 1.3. Got a little sidetracked. So instead of us, you know what, instead of us listing all these, let's just list some that are closer to, I'm going to start off with 1.6. I know, man, I'm in between 1.0 and 2.0. So I'm just going to do 1.6, 1.7, 1.8, 1.9, and then 2. And the reason being for that is because I already know that this is closer to 2 than it is to 1. So I'm not going to list those ones. Okay. I need my calculator now, so hold on. Let's see. There are going to be some when you don't have to do a whole bunch of checking. Hold on. I can't. There we go. Trying to get to my calculator. I'm having to use my phone. So I'm going to take, and you use your calculator to check these 1.6 squared. And since we're doing it this way, I mean, it's easy to check though. 1.7 squared. I guess we are checking. 1.8 squared. I will tell you on some of these it's not necessary, but you'll see it. It's 11 tenths. I think of it like money. This is 11 cents away from being $3. And this is 24 cents of being away from being $3. So I'm going to go with 1.7. So here I'm going to say 2 times 1.7, which is 3.4. And then we can work on the square root of 5. All right, so for the square root of 5, the square root of 5 is in between the square root of 4 and the square root of 9. So that's between 2 and 3. But 5 is really close to 4. So I know the square root of 5 should be really close to 2. So I'll just check these. I won't check a whole bunch of them, okay? We'll just check some of these. I'm not going to do 2 because I know 2 times 2 is 4. So I'm not doing that. So it's 2.1. Let's try that 10. I hate using the phone. I have to keep putting my pen in. 2.1 squared. 2.2 squared. And you'll check too. You can pause the video and check. Pretty close to 5. 5.29. Okay. I know 5's in between these two. So I check. It's either 2.2 or 2.3. This is like 16 cents away from $5. And this is 29 cents away from 5. So 2.2 is closer. And you know what, guys? I wasted a whole bunch of time. No, because I'm going to tell you why. I'm going to scratch all this. Oh, my little brain just didn't kick in. Remember I said sometimes you don't have to check? Well, this would have been one of those times. Because the square root of 5 is in between 2 and 3. So the square root of 5 is 2 point something. Okay? It's 2 point something. Okay, we know that's what the square root of 5 is because it's in between 2 and 3. But look, guys, this is 3.4. 3 point anything. Or 4. You can look at it as 4. It's greater than. It's always going to be greater than 2 point something. It is. You didn't have to finish this one all the way out because the whole number 3 is greater than the whole number 2. So I could have just stopped once I figured out that the square root of 5 was in between 2 and 3. Because 3, the whole number 3, is greater than the whole number 2. Yeah, I wasted some time. I'm sorry, I didn't catch that one. All right, let's take a look at the square root of 12. And if you don't understand what I'm talking about, y'all stop the video and call me over there and I'll explain it. Please. All right, let's look at B. I got sidetracked. The square root of 12 is in between the square root of 9 and the square root of 16. So it's in between 3 and 4. So it's 3 point something. That's 3.8. So I got to be real careful on this one. So I got 3, 3.1, 3.2, 3.4, 3.5. I'm going to check these because I got it's 3 away from 12 and 4 away from 16. So I already know it's closer to the 3 side, but because square root of 9 is 3. So let me start listing and checking. All right, so 3.1, if it was 3.1, I think it's less than anyway because I don't think it's 3.7 or 3.8. Let me check these. 3.7 squared. That's well over 12. That's 13.69. I already know that my answer lies up here somewhere. And all of these are less than 3.8. And that's even without checking. Okay? Now, if you check 3.1, so I'm asking you, you get 9.61. You got to use reasoning skills. That's way too low. If I check something like 3.5, it's 12.25. That's like 25 cents away from 12. That's 11.56. That's like 4 cents away from 12. So the square root of 12 is basically 3.4 is less than 3.8. But I knew it was less than anyway because the square root of 12 I knew was closer to the square root of 9, which is 3. It was closer to that side, so it was less than, I knew it was less than something up here, okay? It's less than 3.8. I definitely know that. 3.8, 3.9, those numbers are close to 4. And 12, which is the square root of 16, and the square root of 12 is not closest to the square root of 16. But, for you to show work, guys, just figure out what the tent is for me. So we are showing work. It's not that hard. I know you can reason it, though. All right, pause the video and try these on your own. All right, this is what you should have had for C. So I'm going to do the square root of 36, square root of 39, and square root of 49. In between 6 and 7. No, 6 point something. All right, so I know the square root of 39 is really close to the square root of 36, which is 6. Okay, so square root of 39 is really close to 6. I'm not going to test a whole bunch of these. I won't be listing all of them out. So 6.1 squared. Too low, 37.21. Let's try 6.4 squared. Too high. That's 40.96. I should have just said we're going with 6.2. 6.2 times 6.2 is 38.44. 6.3 squared is 39.69. So 39 is in here, in between those two. So I can tell you that this is like 56 cents away from 39. And this one is 69 cents away from 39. If you think of it in terms of money, it's easy to do. So what about 6.2? Okay, so that's 6.2. Now I need to figure out, I need to do 3 times the square root of 6. Square the square root of 6. Square root of 6 is in between the square root of 4, square root of 9. So that's 2 and 3. Okay, so I know 6 is closest to 4, so the square root of 6 is close to the square root of 4, which is 2. Okay, so I'm going to stay close to the 2 when I list these out. Okay, I'll start off with 2.2 squared. Just see what I get. Let's start where you want to. That's 4.84. 2.3 times 2.3 is 5.29. Remember, I'm trying to get close to 6. 5.76. 6.25. 6 is in between these two. This is like being 24 cents away from 6, and this is 25 cents away from 6. That was 2.4. So here, this is going to be 3 times 2.4, which is 7.2. So 6.2 is less than 7.2. All right, let's try this one. Let's look at D. The square root of 2 is in between the square root of 1 and the square root of 4. So it's in between 1 and 2. And I'm going to stay closer to 1 because square root of 2 is closer to square root of 1 because 2 is close to 1. So let's list some of these guys. Okay. I can guarantee you it's probably going to be less than, because I'm not testing numbers that are closer to 2. So I don't really want to test 1.7, 1.8, 1.9, and 2. I mean, those numbers are closer to 2. Pretty sure this is going to be less than, but I'm just going to show all my work, okay? So I'll start off with 1.4 squared to see what we get. 1.96, that's really, really close to 2. And I will tell you that this is 2.25. And 2's in between these two. It's closer to 1.4. 1.8 is greater than 1.4. I could have deduced that, though, before checking all of these because I already know the square root of 2 is really close to the square root of 1. So it's going to be really close to 1 versus closer 1.8, 1.7, 1.8, 1.9. I know it's going to be greater because that's closer to 2. And the square root of 2 isn't close to 2, it's close to the square root of 1, which is 1. So reasoning skills, I knew 1.8 would be greater. Square root of 2 would be less. All right, let's talk about this real quick. It says below are exact values involving pi. An exact value is when you don't approximate. if you're not approximating pi, excuse me. If you don't approximate pi, that means you're keeping pi. Okay. So if ever it asks you for an exact value involving pi, leave the pi. Don't change the pi to its approximation. So what are the approximations for pi? There are two approximations for pi. Because pi is irrational and keeps on going forever, we can approximate it to the nearest hundred, or we can use a fraction that's really close to pi. The fraction that we use that's really close to pi is 22 over 7. If you take 22 and divide it by 7, you're going to get something really close to 3.14, really close to pi. So we just use that fraction to approximate pi, guys. It's not equal to pi, but it's the closest fraction we got. That's closest to pi. It's the best fraction we have that's closest to pi. All right, what is an estimate or an approximation of pi? So if we're looking for an approximation of, excuse me, not pi, 5 pi, it's mashed together. So that means 5 times the approximation of 3.14. Or I could do 5 times 22 over 7, the approximation. All right, so when I multiply 3.14 times pi, no, excuse me, times 5, I'm sleeping, to be honest. I get 15.7. It's an approximation. Let me use the squiggly lines. Or if I take this, I'm going to put 5, make it a fraction, put it over 1. So I end up with 110 over 7, top times top and bottom times bottom. And we end up with, 110 divided by 7. I'm going to round it out to the nearest 10, 15.7, guys. Again, this is an approximation too. So I don't care whether you use the decimal approximation or the fraction approximation for pi. Just when you see pi and it says approximate, get rid of pi and use either the decimal or the fraction approximation, okay? It says, what's the best estimate or approximation for pi squared? Pi squared just means 3.14 times 3.14. All right, so that's all that means. So you multiply that out. Let's see what we get. 9.8596. And if you chose to approximate it to the nearest tenth, it's 9. That 5 tells the 8 to go up to a 9. Or you could do 22 over 7 times 22 over 7. I wouldn't really do that, but you can because these numbers get larger. 22 times 22, so we get 44. And 7 times 7 is 49. And when you divide that out, you get, let's see, 44 divided by 49. 9.877, blah, blah, blah. That 7 tells that to go to a 9 if we approximate it to the nearest 10. So again, I don't care if you use the decimal form of pi for the approximation of pi or the fraction form for the approximation of pi. You're going to get around the same answer. All right, let's take a look at this. Here it says compare using less than or greater than, and you're going to use an approximation for pi. I don't care which one you use. So I'm going to go with 3 times 3.14, which is 9.42. And then here for the square root of 8, I know it's in between the square root of 4 and the square root of 9. So it's in between 2 and 3, so it's 2 point something. Okay, I'm going to stop right there. I'm just going to put greater than. I'm not going to waste time doing that because 9.42 or the 9 is greater than 2 point anything. Because 9 is your whole number, 2 is your whole number here. 9 is greater than 2. So the square root of 8 can never be greater than 3 pi. B says what is an approximate value for 5 pi plus 2? Well, 5 times pi plus 2 will be 5 times 3.14 plus 2. And that would be 15.7 plus 2, or I'm going to put 2.0 at adjustment of 0. So that I can line decimals up. So that's going to give me 17.7. And that's how you approximate with an expression containing pi. Last one, it says list the numbers in order from least to greatest. Well, I'm not going to redo 3 pi. 3 pi was already 9.42. Well, I worked twice, but it's already on another page. Okay. So that was 9.42. And I just need to approximate the square of 89. And over here, I'm going to approximate the square root of 85. All right, this is between 81 and 100. And this is between 81 and 100 as well. I already know the square root of 89 is greater than the square root of 85. I'm just concerned about what it is compared to 9 and 4200s. Okay? Each one of them. What's each one compared to 9 and 4200? So 9 and 10. So I'm just going to use one thing to check both of them, okay? So I'll do this. 9.0, 9.1, 9.2. Or I'm just going to check both. I really don't think I need to start that low. Let me flip my phone around. 9.1 squared is 82.81. That's not close to 85 or 89. So I'm going to start off down here with 9.5. It's 90.25. I'm going to go back to see if I'm pretty sure 89 is in between 9.4 and 9.5. Yeah, it is. So 89 is in between these two. 89 is like how many cents from this one? 64. About 64 cents away from this one. And 89 is, it's farther away from, definitely close to 9.4, guys. Okay, so that's like $1.25. Oh, 75 cents. $1.25. Yeah. Yeah, it's too far away. All right, so this is $1.25 away. 94. So that would be 89. The square root of 89 is closest to 9.4, which is the same as like, oh, I need to approximate that to the nearest hundred. Okay, I'm gonna approximate this to the nearest hundred because it's really close to 9.42. You definitely need to approximate that to the nearest hundred. Let me do these to the nearest hundredth, guys. Okay. And the only reason I'm saying do that is because 9.4 is so close to 9.42. I want to be sure. So I'm going to approximate all of these to the nearest hundredth. Okay. All right. So let me go over here and I will do the square root of 85. Where can I? 85. Let's try. Let's finish that up. Let's finish this up with the square root of 85 first. 9.2 times 9.2. 9.3 squared. Okay, so it's going to be closer to 9.2. I don't have to check this one. 9.2 is, I know, less than 9.42. But this one is that's causing a concern. The square root of 89. All right, so the square root of 89, I'm not going to worry about the square root of 85 running to the nearest 100. This is my problem. I know the square root of 89 lies between 9.4 and 9.5. So I'm going to get rid of all this. I didn't need it. Because 85 was in here. In between 9.2 and 9.3. So it can never be close. It can never be greater than 9.4, 9.40, anything, okay? So I'm not going to worry about this one again. This is the one I got to worry about. The 89. So 89, the square root of 89 lies between 9.4 and 9.50. Or 9.40 or 9.40 and 9.50. This one I got to round that one to the nearest 100. Because it's so close to 9.42, guys. Let me see if it's under or over. I'm just going to stop right here. If I need to, I keep going. Let me check 9.42 squared. 9.42 squared is 88.74 if I round it. Oops, yeah, that's going to be close. 9.43 squared is 88.92. Let's see if I can get closer. 9.44 squared. Already I know it's greater. It's 89.11. This is like 8 cents away. And this is like 11 cents away from 89. So definitely, this, instead of using 9.4, let's go with 9.43, which tells me the square root of 89 is greater than 3 pi. Yep, definitely. So now I should be able to order these. Okay, 9 smaller than anything. So the number 9 is first, least to greatest. And then the square root of 85, because it's 9.2. 9.2 is smaller than 9.40 or 9.4 anything. And then we got 3 pi, because it's 9.42. And then we got the square root of 89. And this to the nearest 100 is 9.43. All right, and that's it, guys. Thank you.